Hi guys, and welcome to another video. Today we're going to be looking at, once again, calculus, graph interpretation, or finding the equation of a cubic function. Here we are given a question which I'm going to be looking at from the November 2011 paper 1, question 9. The function f of x is negative 2x cubed plus ax squared plus bx plus c is sketched below. The turning points of the graph of f are t, 2 and minus 9, and s. Function are given to us, and we are required in this question to find the equation by showing that a is equal to 21, b is negative 60, and c is equal to 43, 7 marks. So let's look at it. Now, what we need to do in this particular question is look at what we were given. We are given that the function f of x is minus 2x cubed plus ax squared plus bx plus c, and we are given the turning points. What do we know about the turning point of a cubic function? At the turning point, so we know that the derivative of the function is equal to 0. That's very, very important. So therefore, what we're going to do is we're going to find f prime x equal to 0. Very importantly, at your x value. So what we're going to do is find the derivative of our function, and we're going to substitute these x values in here, and we're going to see what we actually get. So let's look at that. 9.1, let's find the derivative of our function. F of x is minus 2x cubed, so that's going to give us minus 6x squared. So we've got minus 6x squared plus 2ax. That's plus 2ax plus b equals to 0. Plus b equals to 0. And I'm finding the derivative using the rule. So my point of contact, or my x values, now need to be substituted into my function derivative. So the derivative of f. So let's substitute x equals to 2. X equals to 2. So that will be minus 6 times 2 squared plus 2a times 2 plus b equals to 0. So here, if we simplify, we'll get 2 squared is 4 times 6, that's minus 24. And this will be 2a times 2 is plus 4a plus b equals to 0. So we got an equation with two unknowns in it. So therefore, 4a plus b equals to 24, and you can see where this is going. It's leading to simultaneous equations. So now let's substitute. So we substitute one x value of the turning point. Let's substitute the other value. Other value is 5x equals to 5. So that's now going to be x equals to 5. We substitute into the derivative of the function, so we get minus 6 times 5 squared plus 2a times 5 plus b equals to 0. So we got minus 6 times 5 squared minus 6 times 5 squared. Let's just use that, minus 6 times 5 squared, and that's equal to minus 150 minus 150. 2a times 5, that's plus 10a plus b equals to 0. So 10a plus b equals to 150. Now that will be equation 2. So we've got two equations, two linear equations, two unknowns. Therefore, we can now solve simultaneously by subtracting or adding one of the equations, and it will be better for us to subtract here. If we subtract, let's subtract, we'll be able to subtract equation 2 minus equation 1, the b's will cancel off. So let's say equation 2 minus equation 1, and that will now give us 10a minus 4a will be 6a, b minus b cancels, and 150 minus 24. So 150 minus 24 leaves us with 126. 126. Therefore, A equals to 126 divided by 6 gives us 21. So A equals to 21. Let's see if we are on the right track. Okay, so A is 21. So to now solve for B, we can use one of our equations. So we can use equation 1 or equation 2. So let's substitute in equation 1. So if we substitute in equation 1, 4A plus B equals to 24. So therefore it will be 4 times 21 plus B equals to 24. Therefore, B equals to 24 minus 4 times 21. So let's use that. So we say 24 minus 4 times 21 equals to minus 60. So B is equal to minus 60. Let's see if that is correct. So B is equal to minus 60. Alright, now C equals to 43. Now remember that C is the y-intercept of your function. And when we found the derivative, we did not get C. So therefore we have to now use the original equation. If we're using the original equation, what we can do to find C is substitute any one of these points which lie on the graph. Okay, so let us now use the original equation. F of x equals to, now for C we're going to say f of x equals to, and a is equal to 21, so it's minus 2x cubed. So that's minus 2x cubed. And remember now that a is equal to 21, so that's going to be 21x squared, so plus 21x squared. And b is equal to minus 60, so that's going to equal to minus 60x minus 60x, and we are left with plus c. Plus c. So let us choose one point. So I'm going to substitute t, and t is 2 and negative 9. Substitute t, 2 and minus 9. So into my function, minus 9 is the y value, so it will be minus 9 equals to minus 2 times 2 cubed plus 21 times 2 squared minus 60 times 2 plus c. So let's use our calculator to help us here. So minus 9 equals 2. So let's just put this whole part here in the calculator. Right, so I'm going to put this whole part here in the calculator. So that will be minus 2 times 2 cubed plus 21 times 2 squared minus 60 times 2. That's minus 52. So minus 52 plus c. You can see c is equal to minus 9 plus 52. Therefore, we can now conclude that c is equal to 43. So minus 9 plus 52 is equal to 43. Let's see if we can now look at an alternative solution to this particular question. So if you look at this particular question, you found your derivative, which is minus 6x squared plus 2ax plus b equals to 0. So an alternative solution to find, I would say, a and b, be as follows. Right? So we can look at it like this. So as you can see, you've got your derivative function, which is minus 6x squared. The derivative of your function, f prime x equals to minus 6x squared plus 2ax. Right? Now, so if you look very carefully, what do you already know? A is minus 6. X minus x1. What is this x1 and x2 values? Those are the x values of your turning points. So therefore, x1 is equal to 2 and x2 is equal to 5. Those are the x values of your turning points. So therefore, you're going to be left with x minus 2, x minus 5. So minus 6, x minus 2, x minus 5, which is equal to minus 6. X times x is x squared, minus 2x minus 5x plus 10 equals to minus 6 into x squared minus 7x plus 10. Let's take minus 6 into the brackets. Minus 6x squared positive 42x minus 60. So now you know that f prime x, which is your derivative, is equal to minus 6x squared plus 42x minus 60. So therefore, if you equate your coefficients, 42 and 2a, you can now say that 2a equals to 42, 2a equals to 42, therefore a equals to 42 over 2, 21. And if you equate coefficients again, b equals to minus 60. Alright, that's an alternative way in which you could solve for a and b. Remember, if you're solving for c, you would have to use the original equation and go back and do it just like how we did it here, which is use a point, any point, which lies on your function and substitute. Okay? So, once again, a is equal to 21, b is equal to minus 60. Let's look at the next question. So, in the next question, it says, determine the equation of the tangent to the graph of f at x equals to 1 for 5 marks. So let's look at that. Equation of the tangent. Whenever you see equation of the tangent, remember this, that m, your gradient of the tangent to the curve, when dealing with finding the equation of the tangent to the curve, this is what you need to do. M, your gradient, equals to f prime x, the derivative of your function at the x value. And in this case, x is equal to 1. So our gradient is equal to the derivative of the function. Our derivative of the function is minus 6x squared. So we can use it from there. So that will be 6 times 1 squared plus 42 times 1 minus 60. So the derivative of the function is equal to minus 6 times 1 squared. Remember, at x equals to 1. So let's substitute to our calculator here. So minus 6 times 1 squared plus 42 times 1 minus 60, that's equal to minus 24. So that means the gradient m is equal to minus 24. So the gradient is minus 24. Now I need to find the point of contact. So the point of contact, f of 1 equals to. So you have to substitute 1 into your original equation. And your original equation is, if you go back here, there's the original equation. So it's minus 2x cubed. So that will be minus 2 times 1 cubed minus 2 times 1 cubed and plus 21 times 1 squared plus 21 times 1 squared and The next one will be minus 60 times 1. So it will be minus 60 times 1. And remember that the C value we found out to be 43. So we're resubstituting back into our formula. So that will be plus 40. It's 2. So let's put that in our calculator. So we got minus 2. So it's minus 2 times 1 cubed. Oh, times 1 cubed plus 21 times 1 squared minus 60 times 1 and plus 43 equals to 2. So the y value is equal to 2, which means that the point of contact is going to be 1 and 2. The x value is equal to 1, the y value is equal to 2, and we know that the gradient is equal to minus 24. So therefore, to find the equation of the tangent, remember the tangent is a straight line. Y equals to mx c. That now will give us, so the y value is 2 equals to minus 24 times 1 plus c. So therefore, c will be 2 plus 24 is 26. So we can now conclude that the equation of the tangent will be y equals to minus 24x plus 26. Okay, learners, and that's the equation of the tangent. Let's look at the next question. In the next question, they ask us, determine the x. We asked here to determine the x value at which the graph of f has a point of inflection. 2 marks. Remember, the point of inflection is f double prime x equals to 0, and then we need to solve for x. So we need to find the second derivative and equate it to 0. So f double prime x equal. So the second derivative, so let's now go look at f prime x. Remember, f prime x is minus 6x squared plus 42x minus 60. So the second derivative will be minus 12x plus 42. So that will be minus 12x plus 42 equals to 0. Now let's solve for x. Minus 12x equals to minus 42. So x equals to minus 42 over minus 12. Once again, we can use our calculator to just assist us a little bit there. So that will be minus 42 over minus 12. 7 over 2. So the point of inflection will be at 7 over 2 or 3.5. 7 over 2. Okay, learners. So that's 9.1, 9.2, 9.3. Learners, if you haven't subscribed already, please do subscribe to JR Maths or catch all the videos on jrmaths.com. And I'll catch you in the next video.